everyone, this is Jack. Today I'm going to talk about New York City air quality by using Excel dashboard. First of all, I'd like to explain the reason why I chose this topic. My hometown stands in the northeastern part of China. People living there usually suffer from air pollution. The mortality from lung cancer is increasing every year, which always reminds me the importance of air quality. After all of us want to live in a place with clean air. The data I used all comes from the website of United States Environmental Protection Agency, where the integrity and accuracy of the data are guaranteed. And now we are looking at the homepage of the website. It contains many types of reports collected under different types of measure for many years. I used annual summary data in my studies. This is the raw data I used at the beginning. Because there are so many invalid data and unnecessary information for my study, I did data cleansing first. And this is the new table I made. I'll explain some special label names of this table, which may turn out to be essential later. The first two columns are latitude and longitude. They give us specific coordinates of the places that have been monitored. Next column is parameter name. It includes the pollutants and non-pollutants being monitored. There are over 400 parameters contained in the raw material worksheet. In order to make my analysis concise, I picked 5 pollutants as representatives. From here, we can see I applied indicator icon set for the observation count column, which shows us how many times our parameters monitored within a year and whether the data is acceptable or not. Just like the data right here, 37 observations are obviously less than many others for the same type of parameter. The next column is arithmetic mean, which describes the average value of the parameters for a year. I applied bars conditional formatting for this column so that we can see the differences of the amount. I also distinguished different types of pollutants by using different color, which avoids ambiguity. This is the first pivot table for the first max value, and this will tell us the greatest value that has been recorded each year. The changes of the value roughly express the situation of each parameter in the city. So next pivot table is the arithmetic mean of the pollutants. These data basically gave us a general idea about the density of each parameter in the air in New York City. Just giving an example for the data inside cell B3. It means in 2005, sulfur dioxide was measured to be 37.888197 ppb. ppb is short for parts per billion, which is often used to describe concentration of contaminants in air. And please be careful about the rest of the parameters. Their units of measurements may differ from one another, so we cannot simply just add them up together in order to acquire the sum of all the pollutants. That doesn't make any sense, so I took the grand totals of the table. And then the third pivot table mentions about the observation count in different counties. It shows us how many samples were examined each year in different counties. As earlier introduced, the count numbers are essential to researchers who need certain amount of data to conduct valid statistical analysis. So here let's check the count number for benzene in New York County. Comparing the data from other counties, the count is relatively less than any of other counties. in New York City. Its result may be highly skewed, and it will be a big problem if the quantity of data isn't enough. Statistically speaking, the more samples are collected, the less biased the result will be. Inaccurate data may cause health issues for New Yorkers. Let's go back to the dashboard. I created 5 charts in total. Excuse me. The first chart can be used to check the fluctuations of 5 pollutants visually. I also inserted a slicer just so we will be able to clearly see each set of data individually. So once we click one of them instead of showing all, the scale adapts automatically, and it stretches the line so we can see any details we want. The second one is a bar chart. I created it for a close comparison of different amount of pollutants over the years. We can apply trend lines to see a general tendency of each parameter through 11 years. And the third one is a pie chart, aiming to show the percentage of each pollutant in every county. Connecting with the fourth chart, it is designated to show people the sum of observation counts. We can apply a filter, choosing PM 2.5. Within the pie chart, we can find out that New York County holds the most data among all 5 counties. And checking on the fourth chart, it only gives us the whole data observation count all these years. And the last one gives us a sense of 3-dimensionality of the average value of each type of pollutant, as well as the place where they got examined. And finally, since it is difficult to use a single chart to combine all the variables together, I decided to make a power view to observe the relationship among all of them as time went by. So I used average of arithmetic mean as the x-axis, observation count as y-axis, and year as play-axis. The size of the bubble indicates the changes of its first max value. So for instance, according to the motion of PM 2.5, we can actually see it becoming bigger and begins to move to the right top corner, which reveals us the increasing of its amount and the growth of its largest value. At that period, the air quality of New York City is becoming worse. And after 2008, the size of the bubble starts shrinking slowly and moving down, showing the improvement of the air quality. And then we can analyze the remains of the data as well. So that will be the end of my New York City air quality analysis. Since I only chose a small piece of data to complete my study, I think this study may motivate people who are interested in environmental research. So that's all. Thank you very much for watching.